Hello and welcome to GS Podium. To be more clear about the concepts of data structures, we first have to learn data types and abstract data types. So let's get started. Now let's first learn what is a data type. There are two important things about the data types. One is almost known to us, that is, that it defines a certain domain of values. But many of us don't know that it also defines the operations allowed on those values. We know that what is the domain for that value which is to be inserted, but what are the operations that are allowed by that data type? They are not known to us. For example, if we talk about integer type, we know that it takes only integer values, but the operations allowed on integer values or int type is addition, subtraction, multiplication, bitwise operation. Almost all the operations are allowed on integer type. But if we take another example and we talk about float type, it takes only float values, but the operations that are allowed on float type is addition, subtraction, multiplication, division. But it should be noted that bitwise and mod operations are not allowed. Let's learn about user-defined data types. Before understanding abstract data types, firstly we have to understand what are user-defined data types. In contrast to primitive data types, there is a concept of user-defined data types. So, primitive data types are integer, float, character. The operations and the values of user-defined data types are not specified in the language itself, but is specified by the user. That means the user only specifies the operations and the values. For example, structure, union, enumeration. Let's look at the example over here. By using the structures, we are defining our own type, that is point, and we are combining the other data types that are primitive data types, that is int. Now let's understand about abstract data types or ADTs. ADTs are like user-defined data types which defines operations on values using functions without specifying what is there inside the function and how the operations are being performed. That means they are user-defined data types only. Here the operations will be performed on the values, but they will be performed using functions, but these functions won't be specifying what is there inside the function or how this operation will be performed. For example, we take an example of stack ADT. So we know that in stack, the elements are arranged in a sequential order and the elements are of same type. So the operations that can be performed on stack ADT could be initialize operation, or we can say initialize function. So we have a bracket that defines it as a function, but this bracket is empty. We are not defining what is there inside the function. So this function just tells us that initializing it to be empty. We can perform push operation. So push operation defines the to insert an element into the stack. Pop operation deletes an element from the stack. Is empty operation checks if stack is empty, and is full operation checks is stack full. Now think of ADT as a black box which hides the inner structure and the design of the data type from the user. That means ADT is just a skeleton and it hides everything from the user. So there are multiple ways to implement an ADT. So this is very important that there are multiple ways by which the ADT can be implemented. For example, a stack ADT can be implemented using arrays and linked list. Here we can notice that stack itself is a data structure. But yes, this data structure can be implemented using another data structure. Could be array or linked list. But then the question comes, why? Why do we need a ADT? So firstly, we should be clear with some of the terms. The program that uses the data structure is called a client program. The one which does not know the backend, the implementation, it's just using a data structure is a client program. It has an access to the ADT, that is an interface. So here ADT is just a skeleton, ADT is just a black box, and the client just know that there is an interface from where he can use a data structure, but he do not know the implementation of the data structure. The program which implements the data structure is known as implementation program. So this program knows the backend, this program knows the details of the data structure. Now, advantages of an ADT. Let's say if someone wants to use the stack in a program, so he can simply use the operations which are related to the stack without knowing their implementation. So the operations related to stack are push, pop, initialize, is full, is empty. So these are the operations which can be used, but the client program need not to know the implementation, and ADT here is acting as an interface. Also, if in future the implementation of the stack is changed from an array to linked list, let's say the earlier the implementation of stack was using an array, but now it is changed from array to linked list, then the client program will work as it was working before. There won't be any effect on the client program. It will be working in the similar manner. Hence, we can conclude that ADT provides abstraction. That's all for today's lecture. Thank you. Please like, share, comment and subscribe to my YouTube channel, that is GS Podium, and press the bell button for further notifications.